so strange. Yeah, no, because normally there is a class before. I don't know what happened. So.
Wait, did we check the outdoor like?
Anyway. No, because I had a coffee with her. gonna fall asleep. Not a good idea. I thought let's find out what is the optimal level of lighting. All right. Hi, welcome everyone. Just a few things before we start. So first of all, let me remind you, this is week 5, so next week is week 6, which means that it's reading week. So you have the whole week to catch up, make sure that you're on top of things, and that's it, really. So we're not going to have a lecture, we're not going to have seminars next week, just time for yourself. So that's the first thing I want to say. The second thing is that we decided to make, when I say we, I mean I, decided to make a slight change in the order of things that we do in this course. So after reading week, we're going to have a slightly different lecture. So we're just going to delay the lecture that was supposed to be in week 7 to basically the end of the term. I just thought it just make more sense to do that because you need to cover more stuff in here and 4 to 6, but also for in your econometrics course as well, whether that's 4 to 8 or an equivalent EC course. So this is why I made a decision to kind of delay that. It doesn't have any impact on you, rather than just that you need to read the right stuff. But we already updated the reading list, and the Moodle page and everything should be updated and fine. All right. So this is where things are. All right, so let me, as always, any questions before I start, by the way? No? Okay, good. All right, so let me remind you what we did last week, and I'm going to tell you what we're going to do today. So last week, we mainly talked about tradable permits in the first part of the lecture. And then in the second part, we talked about 2 things that complicate our ability to regulate things. If you remember, we talked about space and time. And this week, we will look at further issue that will complicate our ability to regulate the environment. More specifically, we're going to talk about regulation with unknown control costs and regulation with unknown action. Okay, so we talk about adverse selection, moral hazard. And the common feature here is that there is an asymmetric information. Okay? There is a difference in the amount of information that the regulator possesses compared to the polluter. And that's the source of the issue, or part of the source of the issue that we have here. Okay? Most frequently, not always, but most frequently it's the case that the polluter know better their abatement cost, the amount of abatement cost. The regulator, how much it cost them to control pollution, the regulator doesn't necessarily know that, and because this information is essentially private, at least to begin with, okay? And so let's start. This is kind of the most common one, I guess. So let's start with this issue and kind of move things forward as we go along. All right. So again, as I mentioned, difference in information. The amount of information possessed by the polluter and the regulator. And the problem arises from 2 things. Okay, so one is that the regulator and the polluter have different objectives. Okay? So what the regulator wants is the least cost control, pollution control, right? So they want to reduce emission, let's say, from E-private to E-efficient, so they want to move from the market outcome to the efficient level at the least cost. This is what the regulator wants. We've been talking about that for quite a while. And what the firm wants, well, firms just want to minimize their cost or to maximize their own profit. It's not the same thing, right? Because don't forget, if the firms can do whatever they want, they're going to end up in the market outcome. Okay? So there are 2 things actually here that's going on. One is this asymmetric information. And the other thing is that they have different objectives. Because if these objectives were aligned, so they both want the same thing, it doesn't really matter that there is asymmetric information. That's what I'm trying to say here. Okay, so it's these 2 things combined that create the problem. All right, this is one thing that I want to say. And the other thing that I want to say that if you want to, if you, I mean the government, want to impose a regulation in order to reduce emission, in the context of asymmetric information, specifically in this context of asymmetric information, the firm might say that if you're going to do that, we're going to run out of we're going to have to fire lots of people. We're going to have to shut down, et cetera, because this is just too expensive for us to control the emission. And this threat might be credible, or probably is credible, because not necessarily true, but credible, because, again, the regulator doesn't necessarily know what is the true abatement cost for the firm. Okay, so there might be a bit kind of, okay, that might be real, actually. Okay, and as you can think about the political ramification, that might be a serious issue. All right? So again, the issue here is the clash of objective with incomplete information together. This is really the source of the regulatory problem that we are dealing with here. Okay. Let's look at how things are going to work for us, because now we introduce another level of complexity, right? Before we assume full information, now we're going to relax this assumption and see what happened when we relax this assumption. Whether, for example, taxation or cap and trade policy still work as well as what we showed in the last 2 weeks. Okay? Again, the issue here is that we don't have full information. Okay? That's the issue. Okay? All right. So let's look at a very, very simple example here. Okay? The EPA is the regulator, the Environmental Protection Agency in the United States, for example, and there is one polluter. Okay? We're talking about one polluter at the moment. Now, what the regulator doesn't know is whether this polluter is a high-cost polluter or a low-cost polluter. What do I mean by high or low-cost polluter? I mean whether it's expensive for the polluter to reduce their pollution or whether it's very, very cheap for them. So they just don't know which type it is. The only thing that they know, or the thing that they know, is that there are two types and the probability of being each type. At this case, it's going to be very, very simple. We're just going to assume a 50-50% probability, okay? So we just, but that can clearly change very easily. I just made it to make things very, very simple. Okay. Now, what the regulator must choose is, let's go now with taxation, is basically the tax rate, right? So an emission fee, let's call it R, okay? And let's write down the firm's problem, okay? So what's the firm trying to do? Well, firms, as I said before, they either try to maximize their profit or they're trying to minimize their cost. So let's go with cost minimization here. So they're just going to try to minimize the total cost. What are the costs? Well, it's the private cost that they're going to have, right? Plus the tax, right? Don't forget, remember that we talked about taxation, just kind of as a reminder, polluters pay twice, right? They pay the abatement cost plus they pay the tax, right? So even after they abate, they still have to pay a tax per unit of emission. So that's what's going on here. So basically what we showed, I think two weeks ago, what happened if we differentiate that? Well, we're going to get the condition that we've seen before, that MS, the marginal saving equal to the tax rate, right? Okay, so that's what we have, okay? So the firm chooses E, emission level, so that the marginal saving equal to the emission fee, okay? Now, what you can already see from here that, well, if they have different marginal saving, we might going to need two different solutions if we really want to get the efficient level of pollution. But if we just set it at a certain level R and we don't know the exact MS, then we might going to be in a situation that we do get some dead weight loss associated with that. Okay? And let me remind you before I show you the graphical representation of what I just said, is that the EPA goal, again, is to minimize societal costs, right? So it's the sum of the pollution control and pollution damages. So they care both about the marginal abatement cost, or the marginal saving, and also the damages being created, right? This is what they're trying to minimize, both of these things, okay? All right. Let's look at how things work here. So we're going to assume that we know what is marginal damage, okay? We know the function. And the reason why I do that, once, because we're talking about differences in marginal savings, asymmetric information and marginal saving rather than marginal damage, but also like thinking about it more from an empirical perspective, I think that it's fair to say that we have much more much better knowledge about the marginal damage function than the marginal saving. It's just we have lots of empirical paper looking at the marginal damage rather than the marginal saving. Although what I showed you last week, if you remember in the seminar, is actually one very good example when they managed to look at marginal abatement cost or marginal saving. Okay? But in general, there are like thousands of papers trying to think about marginal damages. Okay? In economics, but also in other subjects as well. So we're going to assume that the marginal damage is known. And the problem that we have here is that we just don't know what type of firm we have, in the sense whether it's a high cost polluter, meaning that it's very expensive for them to reduce their emissions, or it's a low cost one. All right? So we have two different marginal saving. All right? This is for high cost polluter. This is for low cost polluter. Okay? And if we had full information, we could have just decided on the level of fees, right? Basically go to the point where the true marginal saving, let's assume that the true marginal saving is H, is just equal to the marginal damage, and then we get this level of fee, for example. And if it's a low one, right, if it's a low cost polluter, we would have gone here. But again, we just don't know which one it is. The only thing that we do know that it's one of these, right? And first thing that we know. The second thing is that there is a 50-50 chance that it's each one of them, right? So what we can also draw here is this line in the middle. This line in the middle, you can call it average marginal saving, or even better, expected marginal saving. And this is when you take all the information that you have into account. Okay, you know it's basically 50-50%, so it's just gonna put it right in the, assume that this is right in the middle. Okay? And you can base your regulation, right, on this expected marginal saving. Right? So if this is the case, right, you're gonna set up the fee at R hat, which is where expected marginal saving equal marginal damage. All right? Now, what's going to happen if this is the case? Okay? Well, if this is the case, let's look at each type of firm. Well, it's the same firm, but let's see what other different scenarios what's going to happen. So let's say that it turns out that this is a high polluter firm. Okay? Again, high cost. So it's very costly for them to abate. Right? So what would have happened? Well, if this is the case and this is the tax rate, they will decide, okay, how much I want to abate and how much I want to abate, right? So they're going to go here. This is the marginal abatement curve, or the marginal saving. Well, here it's cheaper to abate than paying the tax. It's cheaper to abate all the way to this point here, to R hat. Okay? Above this point here, it doesn't make any sense for them to abate. It's better to pay the tax. If we had full information, they actually would have abated more, right? They would have gone all the way here. So what do we get? We get this blue triangle here, and this is the dead weight loss associated with this asymmetric information in this case, right? Because if we had full information, it would have been here, but we ended up being here. Basically, what I'm trying to say that the tax rate that we decided to go with is too low if it's a high cost polluter, yeah? If it is a low-cost polluter, on the other hand, what would happen? So again, they decide whether they want to abate or not. Again, as long as the marginal abatement cost or the marginal saving is below R hat, right? Below the fee, they're going to abate, so they're going to end up here. If we had full information, they would have been here. So basically what I'm trying to say, that this triangle here, B, is the dead weight loss associated if it turns out to be marginal saving of low-cost polluter. Okay? So what's going on here, right? Because we would have been here, essentially what we did, we set the tax rate in this case too high. Right? This is what they abate too much. We should have set the tax lower than that. So again, when there is a 50-50 chance here that it's either firm H or L, then what we call the expected, okay, societal cost, okay, or deadweight loss, would be the average of these two triangles, the area of these two triangles, because it's 50-50. Okay, we don't know which one it is. So that's going to be the expected damage, okay? So there is no single rate here that will eliminate the deadweight loss altogether. These days are gone. Okay? The days of full information, everything is perfect, are gone. What you can do in this situation is to think about what is which is essentially what I did, what is the tax rate that minimizes the deadweight loss, that minimize the average area of these two triangles. Right? And this is basically taking all the information that I had, which is what I did, about the type of cost function that we have for the firms and the probability, right, that it's each one of those, and then set up the tax based on that. This is basically how I created the expected marginal saving function. Okay? So that's what we did. Again, it's not going to be eliminated completely. These triangles will never going to be eliminated completely unless we, try to do something about that. But with one single feed, that it's just never going to happen. Okay? So this is kind of something that's been, that we are using quite a lot. But then you say, look, if we do want to eliminate this whole thing, why can't we just ask polluters? Just tell us the truth. Tell us whether you are a high-cost polluter or a low-cost polluter, right? But if you're going to do that, obviously they have an incentive to lie in some cases, right? So if the firm is a low-cost polluter, right, they will tell us that they are a low-cost polluter because it just makes more sense. You remember that basically if we set up the tax rate based on the interaction, right, between the marginal saving and the marginal damage, they want that to be this interaction here, right, when MSL is equal to the marginal damage, because then the tax rate is actually lower compared to the alternative, let's say that it's a high polluter, right? So that's going to be much cheaper for them. Of course they want to do that, right? But what about if it's a high-cost firm? They also have an incentive, exactly the same incentive, actually more, right? So they want the tax to be lower. So they also have an incentive to lie. So basically the results here, given the kind of incentive structure, is that we're going to have too much pollution, okay? And the fee would be lower than what we would like to be. Okay? And by the way, you can play with it around at home. Think about if that's going to be the same thing for permits, yes or no. It might going to have different incentive structure, actually, with permits. Okay? I'm going to talk about permits in a second. But think about this exact point, whether they have an incentive to lie. What's the incentive for them not to reveal the truth when we have permits? Okay? So what is the efficient or the right thing to do here is actually to find a smart way to, to get around that, right? To kind of make the polluter to tell you the truth, okay? And let's kind of think about it. So basically kind of think about an incentive structure such that this situation is going to be resolved, at least kind of from a theoretical perspective. Again, it's all about incentives, to provide them incentives to tell us the truth. We need if you want to go down this line, right? If you want to be able to eliminate all these deadweight loss, okay? We just need to find a clever way to go around that, all right? So one way to solve this incentive problem is to give a reward R, okay, to the firm H, okay, for truth-telling, right? So to incentivize the high-cost firm to tell us the truth. We have no problem with the low-cost firm, right? Anyway, it's in their interest to tell us the truth. It's really about the high-cost firm that we have the issue with, okay? So we want to do that. So we want to kind of incentivize them to do that, and we also want to do it at the least cost, right? We don't want to spend money that if we don't have to. It's not because we are cheap. It's just because we have, as a government, we have other priorities as well. We want to spend money on education. We want to reduce your tuition fees. We want to give more money to the NHS, et cetera, right? So we need to think very carefully about how we spend our money. Now, we potentially can accomplish that with two different constraints, okay? All right, so let's look at that. So the first constraint that we're going to use is what we call the H-type constraint, okay? And what's happening here? So this is the cost, right? This is essentially the net cost under truth telling. So this is the cost, the private cost for the firm, right? Plus how much they pay in tax revenue, right? Minus the reward they're going to get if they're going to tell us the truth. Yes?
How do we know that they are really telling the truth? Like this is assuming that if we give them money, they will be telling us the truth, right?
We're going to talk about enforcement and compliance later on today, okay? But this is kind of, yeah. Let me kind of show you how we go, and then let's revisit your question in a bit, okay? So they're going to get a reward if they're going to tell us the truth, okay? And this expression here, basically, the net cost under truth telling, should be less, right? Because they're trying to minimize the cost, right? This is why the reward is going with a minus sign here, because it reduced their cost, right? Less than if they lie to us, right? This is their private cost, but here what happened is that they lied to us, therefore we have the fee based on low cost firm. So this is why we have a subscript L here for R, okay? Because we determined the fee based on low cost firm rather than high cost firm. So this is the first thing, okay? So this is the first constraint. The second constraint is that the reward cannot be so high as to encourage the firm L, so the low cost firm, to claim to be high cost firm. Okay? So what's going on here? Okay? So on the left-hand side here, we have the net cost after truth telling. Okay? Again, this is for the low cost firm, right? So this is their private cost plus how much they pay in taxes, and that's going to be less than how much the net cost if they are basically lie to us, right? And therefore, the fee going to be different, but they're going to get the reward. Okay? So this is kind of one way to go around this issue. And it seems like that you can potentially, do you understand what's going on here, by the way? Or some of you look a bit puzzled? Not really, right. Let's go back to basics, right. The problem that we have is that the high cost firm has an incentive to tell us that they are low cost firm. Because if that's the case, right, we're gonna set up the tax at a much lower rate. For the low cost firm, sorry, we have no problem with them, right? They are, they don't have any incentive to say that, they're high cost firm. They don't want to pay more taxes. So we want to induce the high cost firm to tell us the truth. And we're going to, and to do it in the least cost way. So the way that we're going to do that, we're going to set up two constraints, okay, in order to think about, or to change the incentive structure in such a way that it's going to be in their best interest to reveal the truth to us as the regulator, right? So we're going to set up two constraints. We're going to achieve that in two constraints. The first one is the H-type constraint, right? What's going on here? We basically want to make sure that it's beneficial for high cost firm to tell us the truth. This is what happened in the first one here. So on this side here, on the left-hand side, we get the net cost under truth telling, right? This is their private cost for the high firm. This is truth telling because when they tell us the truth, we set up the tax based on high cost firm. This is why we have subscript H for R. This is the true one, okay? And then they're going to get some reward R, okay? Now, the reward R essentially going to reduce their cost. This is another way to think about it. Just one second. On the right-hand side, they don't get their reward, but they're going to pay less in terms of taxes because now it's RL, right? So the tax rate is lower because they lied to us. So the reward, essentially what it does here is to give them incentive to tell us that the true, even though the tax rate is going to be higher for them, the reward compensate them sufficiently such that it's still worth for them to tell us the truth. But what we don't want to happen is that the reward is high enough, the reward is high enough such that now the low-cost firm want to tell us, actually, we are a high-cost firm because they want to get the reward. Yes?
Reward, which I'm assuming is monetary to the company, isn't that undoing the tax as the tax is taking from the...
Well, it depends on the how much it is, right? I mean, you're going to give them some reward, yeah, but
If the reward isn't higher than, if the monetary reward isn't higher than the tax, then it's worth July. But then if the monetary reward is higher than the tax, then it undoes the tax with your
but this is already built in here, right? They're still going to do the right, because we think about it, we're going to set up the tax given all of that, right? So we can totally do that. Sorry, maybe I'm missing something obvious.
I feel like the rewarding is like undoing the tax itself, not because then whatever the cost that they're
No, because, right, think about, right, I see what you mean. So, and it's a good point, but the way that I think about it is in the following way. I always think on the margin. At the end of the day, they have a decision whether they want to abate or not. And they need to pay per unit of abatement. So forget about this lump sum of money that they get, right? I think about on the margin, right? So I think about forget about all of that. I'm thinking about, all right, is it going to be cheaper for me to abate or pay the tax? And as long as it's cheaper for me to abate, I'm going to go with the abatement. All right? Sorry, yes?
So the assumption is the
Oh, there's so many assumptions going on, but I'll tell you about it in a second, yeah.
is that the cost of lying is the same as the cost of the lowest cost firm.
Sorry, say it again.
On top where you have the L subscript, that's the cost of lying and also the cost of the low cost firm.
This guy here, sorry.
The L, yeah.
Yeah, L here, this is basically just denote whether it's, so RL here, that's what you're asking?
Yeah.
This is basically the tax rate when, right, let's go back one. This is the tax rate if we assume that it's a low cost firm. This is how we set up the tax. So it's where marginal damage equal to marginal saving when it's, yeah.
That would be the same as if the high cost firm was lying.
Yeah,
Okay.
yeah, exactly. Exactly. Yes, okay. So this is all very good, and it potentially can work, but it's based on some assumption, as you kind of already figured out, probably. It's based on assumption about the cost type, and if we have all the right things, if all the stars align, we can always find a regulation that induces firm to admit true costs and yields socially desirable pollution. And there is a paper here that I reference that kind of make this case. But also in this paper, they also highlight, and I'm not going to go I'm not going to go at all into that. You can read the paper if you want. It's not examinable or anything. That if, for example, costs are interrelated among firms, or if the damage function are slightly more complex, you have more non-linearities. We're going to talk about it in week 10 or 11. It's not always going to be possible to come up with such solution. We're going to talk about what you say in the second part of the lecture. But that's something that kind of I want you to know. Okay, and more broadly, this whole the whole topic that we covered just now, is also known as the adverse selection problem, that you probably came along in some point in your previous studies here, when you probably talked about the lemon paper or something like that. All right. Okay. About used cars, anyone remember that? The market for used cars? Yeah. All right. So it's related to that. Anyway, the basic point here is that information problems are real, they're problematic, and we need to correct them with some incentive potentially. If we don't do that, we're going to end up in a situation where we're not going to be in a kind of first best, which, by the way, it's also something that happened in many, many cases, right? So again, going back, and you're going to have a question like that in the problem set. What happens if we don't, if we can't induce the perfect information? What do we actually, the right information? What do we actually do? And basically, it's what I said, is to, sorry, I'm going in the wrong direction, is basically going here and kind of thinking about, okay, we're going to use all the information that we have in order to come up with the best policy. In this case, it's the area that is the R or the phi that minimize the average or the expected dead weight loss. Okay. Okay. So this is what I wanted to say about that. Now, the next question that we probably want to ask ourselves, okay, because basically when we talked about full information, we said that permits and fees, right, produce kind of the same results in a way, the same outcome, right? Sorry, yes.
And the point before about averaging out and reducing the,
Yeah.
does that rely on risk averseness? Like, couldn't the state say, well, I'm going to pick 1 platoon 50% of the time I'm going to be right, if you're absolutely not risk averse?
Okay, I'm not following that. So, and then what, if you're not risk averse?
Exactly.
Right, I think that what I'm going to do now, I'm going to potentially answer your question, all right? Potentially, but if not, I'm happy to pick it up, all right? Because we're going to talk about how we want to regulate on that. And I think that what I'm going to show you now, I'm going to tell you that it really depends on the shape of some stuff. And maybe you don't, you need to be very risk loving in order to do potentially what you have in mind, okay? But that's a great point. All right, so basically the theory of full information said, look, you can use taxes, you can cap a trade, you're gonna get, all the great stuff that we talked about, static efficiency, you're gonna go from, the private to efficient and the least cost. It's all great, it's amazing. In fact, we said, if you remember, that with cap and trade, the price of the permit is gonna be equal to the tax rate, right? That's what we showed. So now the obvious question would be whether that's still going to be the case when we have asymmetric information. Are they both exactly the same thing? Because in many situations, as I just showed you now, we don't necessarily going to have information on, for example, the marginal abatement cost or the marginal damage. But I would say it's more problematic to get information, about the marginal abatement cost. Okay? Okay, where are we going with this? Just kind of as a preview, it's not always going to be the same. Okay, in many cases, actually, we're going to have we're going to need to know something about the marginal damage and the marginal saving to decide which one of them, quantity regulation or fees, is better. All right, and let me kind of walk you through what's going on here. Because this is actually a really important proposition that I'm going to show you in environmental economics, one of the most important ones, I guess. Okay. So consider a regulator who can use permits or fees and know the marginal damage function, but not the firm's cost structure. Okay. There is one firm that knows its own marginal saving function. Okay, this is what we have. So let me walk you through what's going on here. So this is very similar to what we had before, right? We have a marginal damage. We assume we know that. We have two different marginal savings, right? Either it's H-type or L-type. You already know what it is. High-cost polluter or low-cost polluter, in the sense of how much it costs them to reduce pollution. All right? The blue triangle represents, right, the dead weight loss associated from price regulation. This is what I showed you before, right? Remember these blue triangles? This is exactly what I showed you a few slides ago. If we use the expected margin, or the average marginal saving, or the expected marginal saving, we're going to set the fee, or let's say at P star, right? If we had full information, we're going to set it up at this point in here. If it's a high cost firm, if it's a low cost firm, we will set up here. And this triangle here just represents the dead weight loss because, for example, the high cost firm, if they are facing P star, they will go and decide to abate all the way up to here. But if we had full information, they should have gone all the way up to here. So they overpollute this A triangle. This is the dead weight loss associated with that. And you can calculate, as I showed you before, what is B. Okay, so we talked about that. The purple triangle, okay, represent dead weight loss from quantity regulation. Why is that? So let's kind of see what's going on here, right? We set the cap, right, where the average marginal saving or the expected marginal saving is equal to the marginal damage. All right, so that's going to be the permit, okay, or the cap rather, okay, the number of permits or the cap, E star, okay. But if we had full information, let's say it's a high cost firm, right, we should have set up the cap higher here, right? If it's a low cost, we should have done it here. So this triangle here, C and D, represent this, the dead weight loss associated with each one of them. Okay? Does that make sense so far? Okay. Well, this is how much, as a society, I guess, we lost, right? Because we always think about the damages versus the marginal abatement cost. So we talked about, I think, in week 2 or something. So here the damages, okay, are higher than the abatement cost. So why would we be in a point like here, right? We much better be in a point like here. It's a Pareto improvement here, actually, essentially, potential Pareto. Okay, so that's what I mean. So this triangle here is just a loss of welfare. Okay. Yeah, I just want to see that I didn't forget anything that that I want to say. Okay. Okay. So this is basically what we can also, you know, zoom in a bit more and kind of see that. But one thing that I want to mention here is that there are very different outcomes. This is just when, you know, when look at the high cost firm, but it's a very different. We get very different outcomes here, right? Because if we set a regulation based on the expected one, right? Where are we going to end up, right? So if we set a cap, right, we're going to get exactly what we wanted, because this is the number of permits that we actually issued, right? But if, for example, we set a tax, right, we're going to end up in a situation where we have too much pollution. You see what I'm saying? Right? Because think about what's going on here, right? If we had perfect information, okay, we would have set up the cap here and the tax here. But we don't have perfect information. So we set the tax here and the cap here. If we use taxation, how much pollution we actually going to get? We're going to get pollution at this level here, right? Because the firm going to think about what is better for me, to abate or pay the tax. They're going to go all the way here. Ideally, if we had full information, we would have gone here. But we did not go here. We just end up being here, right? So we have over-pollution. If we set up a cap, we will get the cap. Arguably, if we had full information, we should have set the cap higher, but we're going to have lower. So the point here, and this is kind of a remarkable result, we get very different situation. We actually get less pollution than what desired. And you can already see, going back to your question, potential consequences dependent on the damage function. If it's a catastrophe to miss the desired level of pollution, so the damages become very steep after this point, for example, depends on the shape of the damage function, you maybe don't want to take this risk. Think nuclear, okay? Think something very serious. You don't want to cross that. With permits, assuming full compliance, we're going to go back to that at the end of the lecture today, you're not going to get more than what you decided to go with the cap. With taxes, you just don't know. Okay? That's the point I'm trying to say. And this is really important, actually, because that might explain a lot of the regulation that we see. Yeah?
Just to clarify, so as a regulator, I do not know the marginal private cost of firms, right?
Yeah.
I know the abatement cost to the extent that at least. And my goal is to minimize my marginal social cost at the tax rate, but I don't know how to do that because I don't know the marginal private cost of firms.
You don't know the marginal abatement cost of the firm, the private marginal abatement cost of the firm.
Yeah.
You don't necessarily know that. The information that you have here in this specific setting is that you know there are 2 types, and there's a 50-50 chance that it's one of them. So you, as the regulator, you're trying to minimize both the cost, the abatement cost, because you don't want the unnecessary spending, and you're also trying to minimize the Yeah, this is basically, yeah, I mean, in a way, well, we did it before. It's basically where the marginal damage equal to the marginal saving. But given that we don't have full information, we just use the best information, which is the expected marginal saving, which is this guy here. Sorry, this guy here in the middle.
And that's assuming only 2 firms, right? So
Yeah, in this specific case, yeah. Just to make things simple, okay? All right, so how we can compare these two possibilities? All right, so because here we have, I was already kind of alluding towards that, but we need to think about what is better here, okay? Here, to me, it looks pretty much the same, right? The purple, triangles and the blue triangles. But let's kind of think about it a bit more formally, all right? So what's going on here? So, right, the expected welfare loss of, for example, an emission permit is given by the following thing, right? So it's going to be this, basically this theta here, right? Time the area of C, which is this guy here, right? Plus 1 minus theta, I think it's theta, right? Time the area of D, which is here, right? This is for, obviously, for emission permits. And you can do a similar calculation, right, for A and B, right, for the taxes. And you can see which one is bigger and which one is smaller. Okay? So one thing that you can see from here, and I can show you that in a second graphically, you can see how the solution for that might change based on the relative slopes of the marginal saving and the marginal damage. So you can, in your mind, kind of move around, let's say you just fix the marginal savings and you can just move around the marginal damages, right, and see how things change. Okay, or do the other way around. This is what I did here, right? So basically you have, in here you have the same marginal saving functions, okay? Again, you have the high, low, and the average marginal saving. And what I did here, I just kind of rotate marginal damage to the right and to the, well, to make it the marginal damage a bit steeper and sometimes it's less steep, okay? And what you can see how the size of the triangles here change quite a bit, depends on how steep the marginal damage is in comparison or relative to the marginal savings, okay? And this is kind of going back to the point that I made before. If the marginal damage are very, very steep, you might want to choose one option over the other. Even if you don't necessarily, I mean, it is all depends on the relative slopes, which I'm going to come to that in just a second, but it's kind of evident from here. But even if you don't really know what is the marginal saving, if you know that the marginal damage is very steep, you can already think about, look, it makes more sense to use, well, in this case, it's going to be something like quantity regulation, okay? And this thing is known as the Weitzman proposition, and this is how it goes, named after Martin Weitzman. This is, I think, a picture of him presenting here at LSE. I went to his lecture a few years ago. He died in 2019, I think, he was 77. Professor at Harvard. This is what he said. It's kind of an important proposition in environmental economics. So what he said is the following: with uncertainty over marginal cost of emission, quantity regulation are preferred if marginal damage are more steeply sloped than marginal saving from emission. Emission fee are preferred if marginal savings are more steeply sloped than marginal damage. So this is basically what I just showed you. And that might explain why in many cases we see much more quantity regulation, things like cap and trade and taxation. We just think that the marginal damage are very, very steep, at least in some range. Again, we're going to talk a lot about marginal damage function and how you actually estimate them later on in this course. But this is kind of very important proposition. So what I'm just saying here is that unlike to what we discussed before when we had full information, with asymmetric information, quantity regulation and price regulation are not necessarily the same. So if you want to choose which one, you need to think about the relative slopes of the marginal damage and the marginal saving. Even if you don't know the exact shape, if you don't know exactly how the marginal damage and the marginal saving look like, if you can just almost guesstimate which one is steeper, that will give you the clue towards what policy you need to choose. Yeah. The marginal damage. Well, we're going to talk about it, but think about it in a way. So what is the marginal damage? What is the cost? What is the damage in monetary terms for, let's say, one more unit of PM 2.5 or something like, or CO2, depends on what you want to do. But let's go with pollution, local pollution, for example. So the way that we do that, going to do it's a whole lecture on that, essentially. But you can think about the obvious example would be the health consequences of that. So let's say, what happened if PM 2.5 in London is go up by 1 unit? How many extra, deaths we see? How many more hospital visits? How many loss of working days and all of that? You can monetize all these kind of things and kind of aggregate them all together, and that's going to give you the marginal damage for PM 2.5. It's not the whole story. There is much more to that than what I just said, but this is just an example. And if it's like very, so why it's going to be steeper or less steep, it depends on how problematic, for example, to human health, PM 2.5 is. So if you compare, for example, the marginal damage of PM 2.5 compared to TSP, which is basically PM 100, PM 2.5 is going to have a steeper marginal damage function because it just creates more damage to your organs, right? It can, cross certain barriers in your body and can reach all the way to the brain, where TSP or PM10 even can't reach that because it's going to stop somewhere else. It doesn't reach the bloodstream, right? So that's, for example, if you compare two different pollutants, which one have a more steeper marginal damage function? Yes. Potentially. It also depends on how much it costs you to reduce the pollution, right? So it also depends on the marginal saving. So the strict answer to that is, well, it depends on the cost of that as well. How much it's going to cost you to reduce these two different pollutants, for example.
And from the research that what's the case?
Well, that's what I'm trying to say. There is very little evidence on the marginal savings. Yeah. But actually, what we saw, we saw some of it last week, but yeah, there is little evidence on that. It's more. I just gave a very simple example. You can think about different kind of, you can think about in terms of climate change. You can think about tipping points. It doesn't have to be linear. Kind of assume almost it's linear in the example that I gave, but it doesn't have to be. Maybe once you cross a certain threshold, the consequences are catastrophic, right? Which is basically the whole some of the literature on tipping points around climate change. So then, you need to be careful there. But that's going to make things slightly more complicated. The main point here is that it's all relative, right? But you need to think about the damages that might be high, which is basically our focus today. But you also need to think about how much is actually to control pollution as well, or emission, to be more precise. Okay. I think that's kind of a great point to take a 10-minute break and then come back. Right? Yeah.
Just to clarify, the star here is the optimal.
Depends on how you say optimal tax.
Because the E star here.
I mean, with full information, it's definitely not the optimal tax, right? Because if you had full information, you would just know which tax you want to set. No, but what I'm saying is that with full information, if you had full information and you know whether it's, let's say, it's H type, you would have set a tax at this level here.
Yeah.
So I guess it's an optimal tax given asymmetric information. Yeah, it's given all of this, all the things that we just talked about.
Okay.
It's kind of I think your best tax rate or the optimal tax rate if you cannot completely eliminate deadweight loss. Basically, by inducing the agents or the firms to provide you the true situation, whether it's high or low cost.
So you mentioned your lecture that the star here is the monitor tab, and the corresponding P star is the background tax.
Yeah, in this situation. Yeah.
And so this MD and MS, they have the same slope as that. So
This is why the triangles look. Yeah.
So the sandwich cost is the same. So there's no preferable instrument.
If they have the same slope, it's indifferent. Indifferent. Yeah. I don't know who was first, but
thank you. For what we said here with that tax leads to overpollution and
yeah.
is my intuition correct that for the overestimation of average MS, so for the L case, it would be the exact opposite?
If what? Sorry.
So we did that example for the high case.
Yeah.
For the low case, wouldn't it be the exact opposite?
Well, they're gonna
That's
be here. Yeah, they're gonna abate too much.
Exactly. But
Yeah,
so then
exactly.
the tax produces actually an underpollution, and the quantity will
But it's
produce.
only one firm, right?
Yeah, exactly. Yeah.
You just don't know which one it will be.
Yeah, exactly. But because we're just expecting the adverse selection up here, that's the case we're conservative. Or
No, but we still. Sorry.
so, like the general conclusion that quantity regulation will.
Well, you know what you get. That's my
Exactly. Yes.
You know what you get. With tax, is less
Right.
clear.
Right. Exactly. Right.
That's my
right.
point.
Okay.
It
yeah.
could be that you're gonna be in a place where you have
Right, okay.
too little or too much.
Yeah. Okay. Okay. Yeah. Good.
But this is kind of
Yeah,
going back to
exactly.
my point about damages. If you really can't cross a certain threshold, do you want to take the risk?
Exactly. Yeah. Absolutely.
That's my point.
Yeah. So there. But I mean.
So think about like a damage function that doesn't look like this,
And then there's hockey sticks at one point. Yeah. But so that isn't, to a certain extent, of course, Tedros Pavlos and all these assumptions, almost a justification for command and control style regulation
Well,
at
but
some point.
why would I? Right. So yes, but I would argue that, as I showed you before, why would you do something like command and control? Well, in some cases, absolutely. That's why I said in command and control. But in some cases, why would you do command and control? Because if, for example, you give them kind of not technology standard, but the other one, right? Why would you just don't let them trade with each other?
Yeah. Absolutely.
But yeah, but this is why I say quantity regulation. I didn't say cap and trade. Yeah.
Yeah. Perfect. Thank you.
I chose my words.
Yeah. Very careful. Yes.
All right.
Thank
Yes.
you.
Yeah. Right. Well, because what we care about, as we said, we care about both the cost and the benefit. If you just look at one side, basically then you're just thinking about the cost. Well, it depends on how you frame it. Or the time and the benefit. Right? You also don't think about the certain or, how much money is spent. I think about both. This is why I care about this. Because we are economists, think about not just because if what you say is if you just think about it, the actual solution, then but we just don't care about how much it costs. But I care about that. See what I mean? No, so it depends on how you construct these things. We're gonna have a whole part in the course about this. So basically, we're gonna go back to these figures and say, okay, how do we actually estimate? What do we think? How do we actually do it? So what does that include, and what we can actually get from different types of estimation? What's the But as a whole, one thing about this, the short answer. marginal damage come from the epsilon. The marginal damage function is the difference between the marginal social cost and the marginal cost. This is the definition of the marginal. So here, so this is when, so on the left-hand side, we get cost under stemming for the local sperm, and this is when they lie, now they are facing a higher frequency, now the technical knowledge, but they get Are you thinking about that? Yeah. We're gonna try to discuss that in some point. Okay. And if not, but then, yeah, I mean, I'm gonna. I need to figure out a bit more well, so I thought that you mean, but then
Exciting for the trading price of carbon.
but no, it doesn't really matter. Okay. For this point, it doesn't really matter. If you omit certain amounts, if you issue a certain amount of assume it's all right, see how many numbers because there are, let's say, 8 firms in that one. You're not going to get more than, let's say, 8 firms. With taxes, too low, for example, then you get what to say. All right. Back to your seats, guys. Okay, so so far we talked about a very specific form of asymmetric information where when they're regulating polluters, when regulators lack information about the polluter characteristics, okay, where it's a high or low firm, high or a low cost firm. Now we're going to consider a different form of asymmetric information, where the polluter takes an action that the regulator cannot observe, okay? And we're going to try to see whether we can develop a form of regulation that will deal with this type of asymmetric information, okay? So let's kind of consider a very simple case to explain to you what I mean by that and see whether we can actually deal with this adverse selection issue in this case, all right? So consider one firm and one regulator, again, the EPA. The firm is required to undertake some pollution control, but the regulator cannot observe effort devoted to controlling it. Okay? So the firm undertake an abatement, some form of abatement given by A, which is observed by the EPA, okay? And also maintenance or operating effort F, which is not observable. Okay, so we can, for example, tell the firm, look, you have to install a certain filter or whatever, but we just don't know how well they maintain the filter. Okay, or certain equipment, it's just we don't know how well they maintain the filter. Okay, now an increase in F, okay, in the effort results in lower emission and higher cost. This is a real thing, by the way. Okay, so we can, for example, let's say put which we kind of do in several studies right now. Put, for example, an air purifier, okay, which is a technology, but we don't know how well people maintain it. So do they replace the filter? They don't. How do they do? Do they actually use that or not? So we don't know about what's going on in the maintenance or the usage. Okay, so this is a real world story, real world situation. And you can think about it in terms of the factory, where they put a filter, but do they actually service that? If they don't, it might not going to work that well. That's the point about an increase in F probably going to lower emission, okay? Emission are denoted in the following way. So E, emission, depends on two things, right? One is the abatement technology, but also on the effort. But these are unobserved by the EPA, right? The full amount, okay? Why? Because we just don't know what F is, okay? The EPA can only control abatement. It can require the firm to undertake some level of abatement A, okay, but not direct control over overall emission, okay, because again, it depends on F as well, okay. So let's see what's going to happen in this situation here. The polluter's goal is to choose the level of effort in order to minimize the cost. So this is what's going to happen here. So they're going to minimize the cost. Again, the cost depends on two things. One is A, which is again the abatement technology, but also on the effort. Obviously, if you want to maintain, for example, change the filter or have more maintenance people that working for you, that's going to be more expensive. And they can choose the level of F. They can't choose A. That's been determined for them by the regulator, let's say. But they can choose the level of F. And F can vary between FL and FU. This is lower and upper bound. Okay, so you can invest a lot in maintenance or very little. And note that basically F is costly, right? So it's going up in effort. So the cost is going up in effort. That's what I'm trying to say here. Okay. So what firm will do? Well, they will choose, right, the lowest possible F that they can, because they're just trying to minimize the cost. Again, I'm assuming the worst about firms, right? They're always going to do the minimum in order to make sure that they maximize their profit, which I'm not sure if this is actually a bad assumption to make, okay? Now, the EPA goals, right, is to minimize societal costs, right? So it's to minimize, I think this is going back to the point that you asked me before, right there, is that they're going to try to minimize the cost, right, of the firm, essentially, but also minimize the damages, okay? D here is the damage function, and the damage function depends on emission. This is kind of going back to the point that we discussed before. What's the damage function, where it's coming from? I just mentioned the point about the health consequence. It can be other stuff. But at the end of the day, it really matters. It depends on pollution and emission. And emission here is determined, as we said before, by by abatement technology, and also by the effort, okay? So two things here are actually affected by F, right? So one is the cost for the firm, the private cost, right, almost, okay? But it's also affect the damages, obviously, right, because it affects emission, okay? But again, EPA cannot control that. It cannot control F, okay? So let's look at this whole thing graphically, okay? So we have the marginal damage and the marginal saving, or the negative of the marginal cost, whatever you want to think about it, or the negative of the marginal damage. It looks weird. Why is that? Because we don't have emission here, we have abatement, which is the opposite of emission. Okay, this is why the marginal damage function are downward sloping and the marginal cost look like that. Well, they here, rather than the marginal savings. Okay. So what's going on? Okay, so what I'm going to try to show you, that if we had full information and everything was perfect for us, we would end up in a place like A star. Okay, this is where they put the optimal level of of effort. Okay, and this is the optimal effort. This is the marginal cost when they have the efficient level of effort, and also the efficient and the marginal damage when there is the efficient level of effort. Now, if they don't put the efficient level of effort from a societal perspective, and they're going to choose FL, right, which is the lower bound amount of effort, so the minimum effort that they can put in, right, the marginal cost is going to move from here to here, right, because the marginal cost is going to be lower now. Okay? But as I said before, right, what's going to happen? Well, it's not going to affect only the marginal cost, right? If you go back here, it's also affect the damages, right? Because the damages are also affected by F. Right? It's going to this function here because it's going to the damage function because it's essentially affect emission as well. So the damage function also going to move. Okay? So both of them going to move, and we're going to end up in this point in here. So essentially what's going to happen is that in this situation, the EPA will ask for more abatement than it's actually necessary. Okay? So again, if EPA has full knowledge of F, then there are optimal levels of abatement and effort, which are denoted by A star and F star. That's what I said before. In practice, firm will choose the lowest possible F that they can, okay? And to compensate for the low effort, the EPA must require extra abatement, okay? So this is basically what I just showed you, why you're going to end up in abatement which is higher than the absolute necessary if we had full information. Okay, the second best solution involves control costs and damages that are higher than under optimal policy of A star and F star. Basically, again, both of these curves moving because F affects both the marginal cost and the marginal damages. Okay, this is what's going on here. So what are this is just kind of the background. Yes?
What would happen if the firm chose FU?
Why would they do that? Yeah, so basically, so they, so I guess that we're going to have less pollution. But the EPA would, so according to this, the EPA will decide, they will think unlike you. Maybe they are just different type of people. They think like me, the worst of firms, and they're going to think like they're probably going to use the lowest. So they're still going to assume, I would argue, still going to assume that it's FL. And then at the end of the day, therefore they will require more abatement. And we're going to end up in a point when we have way too much abatement, right? Because actually they put a lot of effort into that, or too much emission rather. Sorry, too little emission.
So then the FU boundary is useless, basically.
It's not useless. It helps us to think about the different type of the theoretical action that firms can take. They can do a lot or the very minimum. So I think from a practical perspective to design the policy, the way that we think about it, I agree it's useless, but from more kind of conceptual way about thinking about what firms can do, they can, in theory, they can do that, yes. And by the way, I'm just taking obviously extreme cases. They don't have to go all the way to the bare minimum, right? They can do something in between, right? Right, so solution to, yes?
One short question regarding the last sentence of the previous slide. As I understood, we have like in the AL, we have more abatement, so we have less emissions.
Yes.
But we have the second best solution involves like extra damages that are higher than under the optimal policy. It's like the environmental damages that are higher, but we have less emissions.
This is abatement here, right?
Yeah.
So, sorry, I'm missing your point.
Like we have under the second best solution, we have more abatement, so we have less emissions.
Yes.
But why can then the damages be higher than under the optimal?
Sorry, this is why I'm not following. Why is the damages are higher?
The last sentence says this second best solution involves control costs and damages that are higher than under optimal.
Oh, okay, sorry, here. Okay, this second best solution involves control costs and
Or it's like
the marginal damages. Sorry, it's basically the whole, yeah, because, oh, I see what you mean. Hold on, let me think.
the total environmental damages are higher, but the marginal damages.
Let let me see what I'm trying to say here. The second best solution involves control costs and damages. Okay, the control cost is definitely going to be higher. Why the damage is going to be higher than under, yeah, I think I'm talking about the marginal damage functions rather than the actual, I see your point is that we basically abate more, therefore the actual damage is going to be lower. Yeah, I think, yeah, you're right in this case. But what I think that the point here is that the,
Like the total cost, the control cost plus the damages are higher than invested.
that's certainly the case. But you're absolutely right, right? So I think that the damage is definitely going to be lower than that because we abate more than what we should have. So just in terms of the damages, they're going to be lower. Totally agree with that. But I guess that, yeah, I think this is what's going on here. So it's maybe the totality of both of them going to be lower. Yeah. Now, what we can, yes.
Is it not just that you're comparing the ideal situation with A star and F star against a situation with increased abatement but lower effort? So the marginal damage can still be,
That's exactly what I'm doing, yes.
yeah, the marginal damage can still be greater. Like you can still have more CO2 emissions with higher abatement.
The marginal damage, sorry, what's going to be higher?
Well, so the reason why the marginal damage is higher,
Yeah, but I think that your point is that if we actually, basically in the second best, right, we're going to require more, right, and therefore there's going to be more abatement, right? And if there is more abatement, there is less emission, and therefore damages are lower than that because of that, right? That was your point, if I understood correctly, which I don't disagree with that. But I'm happy to rethink about this and come back to you by the end of this lecture, okay? If I'm missing something obvious. Kind of, I'm going to think about it in the background. But I think that makes sense to me. Your point is that, if I understood it correctly, that we compare like different scenarios, right? But I still, you know, yeah, I mean, the other thing, yeah, I see what you say. I need to think about it for a bit, okay? Let me think about it, I'm going to come back to you. Let's do that. I don't want to make something that, I don't want to make a wrong thing. Right, if we are, right, let's think about it for, now you annoyed me. Okay, so if we decide to, if we don't have perfect information, right, then we ask them to abate more because they are going to put less effort. So we're gonna end up in a situation when they have more. They're gonna spend definitely more money, right, on that. But then we're gonna abatement gonna be higher. But then actually, right, because because now the F is lower. So then the product is actually, it depends on two things, right? It depends on the effort and on the abatement. Right? So there are two things that actually will affect actual emission, right? Because A here, abatement is just the, yeah, right. Let me do that. Let me think about it, and I want to write to all of you what's the right answer here. I don't want to make a mistake, all right? So let's kind of come back to you later on this one. All right, how do we actually solve the problem? Let's kind of do that. Sorry about that. All right, so one thing that we can do is to perfectly observe emission. This is something when I start teaching this course, I would think this is ridiculous. We cannot perfectly observe emission, but with with improvement in measuring and especially with satellite imagery, I think that we're in a much better position compared to where we were like maybe 10 years ago. So we can do lots of stuff around that. All right, this is one thing that we can do, but again, it's not always feasible. The second thing that we can do, we can imperfectly observe emission to do spot checks on emission level or something like that. And the third thing is to identify a variable that is correlated with effort. For example, observe something like maintenance, staffing. How many people actually work in the maintenance department or something like that. Again, it's not perfect, but it's something that can potentially work. So going to the first point that I tried to make about perfectly observing omission, this is something that I didn't think it's going to be possible, but a few years ago, before COVID even, I gave a talk in the University of Maastricht, or Maastricht University, I don't remember which direction it goes. And there was a guy from Airbus that showed us these figures here. And what you see here, this is from one of the products. I'm not trying to sell you the products, by the way. So I'm not saying that you even need to use that. But basically what you see here, you see how they, with their product, can actually look, in this case, an NO2 emission from space, okay? And they can actually see an attribute, in this case, NO2 emission for a specific plant in India. In this case, you can have another one for a cement factory in Nepal. So you can just use satellite imagery in order to get really good information about emission. Okay? Don't forget, before that, we didn't really have information about emission, right? So you can totally do that these days. I use a lot of satellite data. Just kind of one point that I want to make is that make sure that the product that you use is pretty good, right? And there are different ways to do that. In fact, there is a public lecture on Wednesday that I'm going to be on a panel with Department of Statistics thinking about how we can use different data sources in order to kind of think better about environmental regulation, et cetera. So if you're interested in that, it's going to be on Wednesday at 6 o'clock. Okay. I'm going to do very little there. I'm just going to be on a panel. So there is a professor from statistics from a different university come to talk, but if you want, you can book your tickets and come by. I'm going to try to think about something clever to say, all right? But seriously, like one thing that you can do, you can test to make sure that the quality of the data is good. You can test. So, for example, I have a paper with a colleague from here as an urban economist, Felipe Carozzi, in which we look at the relationship between density and pollution in the United States. And the problem that we had is that we don't have we have good information about pollution in the United States from a measuring station on the ground, but it's not perfect in the sense that there is a lot of, pollution monitors are not randomly assigned across space. So you normally put pollution monitors where there is population centers or some other reasons why you want to put pollution monitors in. It might, by the way, go the other direction in the sense that maybe you don't want to put pollution monitors in certain areas to avoid showing that you have high level of pollution. Depends on who you are and what you're trying to achieve. But basically the point that I'm trying to make here is that we took this kind of satellite data, but we didn't know how good it is. Other people used it, but we didn't know how good it is. So what we did, we know the grids, and we know that in some parts of the United States we have pollution monitors. And we know that the pollution monitor is pretty good. So we can take all the grids that, it's like 1 kilometer square, so it's like 0.01 degrees. So obviously it depends on where you are on the globe, but let's say that it's around 1 kilometer square. So we know here in this square we have a pollution monitor. So we can compare what the pollution monitor on the ground tell us and what the satellite tell us as well, right? So if this is highly correlated, then we know that, we have a good product. This is just one example of how, for example, in dissertation you can test, almost do like a sanity check to check whether the product that you have is good. And in our study, I think it was the R-square was 0.83. So we thought it's a good thing to use. By the way, we used the same product in a different country, not in the United States. We got a very, very different result. In the sense, it was awful. Okay. When I say we, it was like basically a former ECC student that worked for me as an RA and did kind of a global study, kind of looking at where it works and where it's not, because we thought about big project, and they discovered that. So that's something that you probably want to know. But again, if you're going to think about dissertation using this stuff, I'm happy to talk more about that. Anyway, going back to our kind of lecture. If polluter can take secret action, it may be difficult to obtain socially desirable level of effort. To get firm to undertake socially desirable effort, the regulation must be aligned with a firm incentive. We call this problem hidden action, the moral hazard problem. How do we handle problems where we cannot observe emission perfectly like we do here? Okay, so let's look at this at the following example. So we observe an ambient level, but emission is unobserved. Okay, so it's either too expensive to monitor, or there is just inability for us to monitor the exact emitter. And I will show you now that there are some regulatory systems that can, in principle, work in this setting. So let's consider the following example. There are two farmers along a river, going back to the river example, two random names, Trump and Biden. Trump raises chicken and Biden grows vegetables, okay? P is the pollution level downstream. So again, there are two US presidents that are farmers now, and they kind of do their operation along this beautiful river, and they cause some pollution, all right? Let's give you some more details. EI is the emission level for I, and I can be either Trump or Biden. AI is the transfer coefficient. Remember that from last week? This is how each one of them contributes. So basically to pollution at, let's say, the city, it just depends on essentially the distance, right? So the distance between the source and the receptor. The optimal level of pollution from each farm is the one that equates marginal saving from emitting to marginal damage in emission terms. Remember, we talked a lot about that last week. We want to talk in the same kind of language because the cost of reducing emission is in emission term, and the cost of the damages are actually in pollution terms, so we can use the transfer coefficient in order to translate emission to pollution. So this is what we get. We get the negative of the marginal cost of emission equal to the marginal level of emission, or the marginal damage of pollution times the transfer coefficient, and that's true for each one of them, for Trump and Biden. The problem that we have here is that E is unobserved. Okay, we don't know what is the actual level of emission. However, the regulator observed P and the transfer coefficient. So how is that even make sense? Well, they might be able to know what's the they know what is P, right? That's easy to find out, relatively easy. And they can, for example, get a good understanding of the transfer coefficient given, let's say, the distance, right, between the source and the receptor, okay? P star be the optimal amount of pollution, the level that just balance costs and damages as always, all right? So let's consider a tax here, okay? What's going on here? Tax is equal to T times P minus P star. What does that even mean? So if P is greater than P star, then each firm I pay a tax T on the amount exceeded, okay? If P is less than P star, then each get a subsidy, which is equal to T. Okay, so it depends whether P star is above P, whether P is above P star or less than P star, okay? We can write Biden problem in the following way. So Biden would try to minimize their cost, right? Which is given by this expression here, right? So this is kind of the cost, the private cost, right? So the cost for Biden, which depends on the emission, plus the tax rate or the subsidy they're going to get essentially, which depends on basically the tax scheme that we establish here, which depends whether P is higher than P star or not. We can rewrite that in the following way, right? And then we get this expression here. What is that? Well, this last bit here, right, is something that Biden can't really affect. This is only depends on basically Trump's action. So we're going to take this whole thing as a constant in our minimization problem, okay? So we can just progress to this bit in here. We can take the first order condition of what we have, set it equal to 0, and we get this kind of normal expression that we got before, which is the marginal saving equal to the tax times the transfer coefficient, okay? So to achieve a social efficiency, we need to set T such that T equal to the marginal damage of pollution. With knowledge of this value of T, we can see that the Biden and Trump will choose emissions such that the marginal saving equal to the marginal damage times their specific transfer coefficient, okay? So the results that we got here, that with a single tax rate, okay, charged at both farmers, we're going to get what we want. Now, it looks too good to be true, and the truth is that it is good to be true, because look at that, what's going on here, right? Because what I'm saying here is that we're thinking about the cost for Biden. In this situation here, there are only two farmers here, or two polluters, so it's not a big issue. But if we think about, hundreds or thousands of polluters, we're going to talk about significant amount of transfers, okay? Which are obviously going to make this thing impossible. All right, so from a theoretical perspective, that kind of makes sense, but from a practical perspective, that seems to be very unlikely, okay? Okay, now we have like half an hour or so. Let's kind of consider a related problem, but it's of moral hazard, okay, which is basically thinking about, related to what we talked about actually when we talk about taxation, when we think about midnight tapping. So what do I have in mind here? Let's say that we have a polluter, and the polluter has two choices, right? One is dispose hazardous waste safely in a regulated facility, or in the other way, dump them in the middle of the night illegally. And we talked about it when we talked about the Charlottesville paper, remember? So there are two options for when we put a price on a bag of garbage. We can either do what the regulator wants us to do, or we can do something that is not socially desirable, okay? So this is kind of where we are, and since it's cheaper essentially to go with a less sociable way to dispose your garbage, the polluter is potentially or even likely to prefer to do that. Okay. So how can we deal with this situation, right? To basically impose a tax, but the firm might don't want to pay the tax in a way that they're just going to do something that is not socially desirable. So one solution would be to subsidize the safe disposal, okay, of the waste. That's going to make it more attractive for firms to actually use safe disposal. Okay. So how are we going to do that? Right. So this is the firm's cost function. Total cost here, okay, depends on whether the firm decide to safely dispose their waste or not. If they dispose it safely, they have the following thing, right? So this is their private cost, right? So CS depends on how much waste they actually dispose, minus the subsidy they will get for safe disposal. If they don't do it legally or illicitly, right, to be more precise, then what they're going to have? Well, they're going to have just this guy here. Now, note this is not the same, right? Because this is here have a S subscript compared to I subscript. Obviously, I subscript here means that it's going to be cheaper for them to go with this option here. But what we introduce here is that we also have this subsidy, essentially, that we want them to get in order to nudge them, right, to move towards safe disposal, okay? Or to convince them to go there. So again, WS here is if they dispose their waste safely, and WI is whether if they dispose it, dispose the waste unsafely, okay, or illicitly. This is what I said before. Again, it's cheaper to dispose it illicitly, right? So we need to choose S such that we get this identity here, the cost, okay, of safe disposal minus the subsidy that I will get, right? Again, the subsidy go into the cost function with a negative sign because it's actually reduced my cost, right? Is less than the cost of if I do it illegally. Okay, so what is the problem with doing something like that? Or is there any problem? What do you think? Sorry, say it again.
How do we know the cost of doing?
Wow, this is a great point. So one, how do we even know how costly it is? But we assume that there is some cost, and we know that this is probably cheaper. So it's just cheaper, for example, not to price for them, right? Privately, not the social cost. It's probably cheaper for them, for example, to take the garbage to the university rather than actually pay the 80 cents of the bag or something like that. But it's a good point about we don't know how much it's going to cost them to actually take the garbage to the university. There is some kind of disutility from doing that, et cetera, et cetera, et cetera. But what else? What other issue we have here? Yeah. Exactly, right. So we basically give some incentive for firms to, or anyone, to just produce more waste because we provide subsidies for creating more waste. This is actually written here. I just want to make sure that everyone is on board. Okay? All right. Right, so what we're going to do here in order to solve that, and this is something that is actually being done a lot in reality, and I'm going to give you an example in a few seconds. We're going to find an observable action on the part of the firm that is correlated with waste generation, but unaffected by the choice of disposal method, and we will tax this behavior. Okay, so let's consider such a system. So again, we're going to tax part of the operation, basically something that is completely unrelated to how we decide to dispose the tax, in order to avoid to dispose the waste, in order to avoid the point that you made just right now, right? Because we just don't want them to just create more and more to get a subsidy, so we're going to try to discourage that behavior. But we're going to give some, some kind of treat, so to speak, for safe disposal. And I think this combination together might solve that, and you will see that you probably use that, or you've seen that kind of policy in real life, okay? All right, so generation of waste, W is observable, disposal is unobservable, expects when done safely. So we just don't know if people dump it illegally. We just don't have that. We know that's good as don't have this kind of amazing measure in this paper, we just don't have that. DI, W here is the damage from illicit dumping, DS is the damage from safe dumping, and again, we're gonna make this assumption that it's just cheaper to dispose the waste illegally, okay? Otherwise, we don't really have a problem. But I agree with you, your point that we don't know exactly what it is. Okay. Again, the solution here is going to be tax waste generation at a rate T, and then we're going to subsidize safe disposal at a rate S. Okay. So what we're going to do, again, we're going to tax the waste generation, and we're going to subsidize safe disposal. These are two different things. Okay. So the firm cost is going to look like that, right? So we're going to have this expression here, right? This is if safe disposal use, right? So they're going to pay. This is the private cost plus how much they need to pay in terms of the tax. The tax will depend on how much waste is generated. So they definitely have now clear incentive not to generate a lot of waste if they don't have to because they're being taxed on that, right? This is this TW. But now their total cost function will be reduced if they safely dispose their waste. Okay? So this is what's going on here. Compared to if they do it illicitly, right? So here they have different costs, which is going to be lower, but they're not going to get a subsidy. They're still going to have this feature here that they still need to pay for the amount of waste that they create. Okay? So just let me finish that, and then I'm going to have two questions here, okay? So how much waste will be generated? All right, so WS is the waste generation if safe disposal is used, and WI is the waste generation if illicit disposal is used, okay? We tax, okay? So we can get the first order condition, and this is what we're gonna get, right? So we're gonna get marginal saving equal to T minus S for safe disposal, and if illicit disposal is just gonna be equal to T. We also probably want to ask ourselves, what are the optimal choice of S and T, right? What is the right level of subsidy and tax given the situation? So S should be set so that costs with safe disposal are lower than with illicit disposal. So we want to set the subsidy in such way that it just make more sense, right, for the firms to safely dispose their waste compared to if they do it illegally, right? And if safe disposal is feasible, then we also want the socially efficient level of waste generation where basically we get marginal damage equal marginal saving, right? So we can basically use these two expressions here. So the firm, and there are different subsidies, but what we want to do is to want to make sure that we're going to get a subsidy, the least cost subsidy that's actually going to get us to this point in here, okay? And we're going to get this expression here because we want to get the smallest as possible, right? We want to get the smallest subsidy. We don't want to spend money if we don't have to. That's my point here. So in order to do that, we're going to allow for debt to be held with equality. What does that mean, this expression held with equality? It means that they're going to be indifferent between dispose the waste safely or not. So if they're indifferent, they might as well, or epsilon more on do it safely, okay? But you can think that if it's basically the same for them to do it, legally or not legally, they're probably going to go legally, I think, right, or illicitly. Do it in a socially desirable way. But if not, you can think about an absinthe more for safe disposal. And basically, you're going to get this expression here. Again, if you hold one with equality, okay? So I omitted a lot of steps in order to get to S star here, but in the book, it's actually show you exactly all the points, and I strongly encourage you to make sure that you get basically from these equations that I showed you here to S star, because it's actually going to be very helpful. If you can't get it after a few attempts, feel free to come to my office and I'll show you how to do that in 5 minutes, but I want you to struggle a bit more before I do that, okay? So what's going on here? So this expression here is the firm saving from dumping, right? And this guy here is the West generation tax saving for the firm from illegal dumping, okay? And this is basically just going to be normalized by per unit of waste being generated, okay? So if you think that this sounds like a bit academic and what it actually means in reality, so let me kind of give you an example. So let's say that you're thinking about, I don't know, something like bottled beers, all right? So you can tax the amount of bottles that you generate, right? And you can say that the tax is equal to whatever times the number of bottles to be generated, easy to do. And then you can only see whether people, for example, return the glass bottle to the store or not. If they do it illegally, they're not going to get anything. If they bring it back to the store, they're going to get something back. So this is kind of similar to the system that I just explained. So you tax the generation of waste, which is the bottles of beers that you actually create, okay? And you subsidize safe disposal of the bottles that they bring it back to the store. This is the same kind of system that you have in place here, okay? So this is kind of, the point. In order to get the, I had some question before that I missed, so let me take the question first. No, the problem is that if I give incentive for firms or subsidy for firms for safe disposal, not in the way that I did it, I might or for disposal, I might gonna create a situation when firms have an incentive to just produce more waste because they get money in return for the waste. That's what I'm trying to say.
In a real world sense, wouldn't you subsidize the cost of safe disposal, rather than it costing you £20 to put your bin in a trash can, it will cost you like 10. So how does that incentivize them to produce more waste than if they were disposing it illicitly?
Sorry, say it again.
My point is, how does it incentivize them to produce more waste than they would have if they were disposing it illicitly, illegally?
If you do what? I'm a bit confused about that. So if, let's say, right, so basically the point is, the big picture point is the following. If I tell people, look, if you give me your waste, I give you money, that gives them some incentive to give me more waste. That is my point. And what I'm trying to do with this system here is to kind of say, okay, fine, I want to deal with that. I don't want to give them this incentive to create more waste because they're going to be taxed on that, but I definitely want to give them some incentive to give it back to me safely, and I'm going to give the subsidy if they're going to do it safely. That's what I'm trying to do here. I'm not so I'm not subsidizing necessarily the cost of safe disposal. I'm just give them incentive to do safe disposal. Sorry, if that makes sense.
Sir, on a similar point.
Yeah.
So if you want to incentive, right, that subsidy has to be greater than the tax, right? So
No.
no.
No, because you've been taxed, right? So I tax for the number of, so when you buy a bottle, the tax price is already priced in, right? So you already pay, let's say, Now the decision, because I want to incentivize safe disposal, is whether you bring the bottle, the empty bottle, back to the store or not. So it's unrelated to the tax. Because the price is, the tax is already in the price that you bought. Everyone paid that. Now your decision whether you want to just basically throw it in the middle of the street or not, it depends on the price of the subsidy. Now you might want to say, maybe going to your point here, you might going to say, it's a great point. So like, look, you know what? It doesn't worth for me to go all the way to the store to get like 25p. That might be the case, but then maybe two things. One, you can say, I'm just thinking loudly here. One, you can say maybe you didn't set up the subsidy in the right way, to the point that you're actually going to get safe disposal. The other thing that I might say, this is what you see it all over, you see people that it definitely worth for them to collect these bottles and bring it to the store. Right? So maybe for you as an individual, it doesn't worth it if this is what you had in mind in terms of the cost of actually bringing it. But for someone else, it might be worth it. And I see many people, well, it used to be more, but you see people like with lots of bottles go to Sainsbury or whatever to get the money there. Okay, so it doesn't have to be for you individually, but for someone it makes sense, yes. But hold on, but what happened if, right, so if you have, what happened if you get caught? Okay, so let's talk about that. I think something that's basically going to deal with that. Okay, with basically, I think what I'm going to do now, I'm going to answer your question. Okay, I hope so. Right. So kind of in the last few minutes that I have, very last few minutes, let's look at the following situation, because that's really important. Okay. There is a special case of incomplete information which involve identifying polluters that are not following regulation. Okay? This is a relaxation of our implicit assumption so far that firms do as they are told and are voluntary provide private information. So the general setup is going to be the following one. The regulator can audit firms, but at a cost. So I can audit firms, but it's going to cost me some money. And enforcement takes two places. So first things I need to find out is who actually are the violators, which is expensive, right? Because I need to go and check. And two, are going to have to penalize them, okay? So the goal for us as a regulator is to induce compliance at the least cost. So let's look at a setup. Firms emit pollution E at some cost, and again, if they emit pollution, the cost is decreasing. Basically, the point is that abatement is expensive or costs some money. Firm report emission to the regulator. This is, we're going to have to trust them. We don't have full information, or maybe we don't trust them. Then we have a probability of being audited by the regulator. And suppose that each firm faces an emission standard of S star units of pollution, okay? If the firm is audited and exceeded the specified level of emission that they are allowed, S star, then it must pay a fine, F, per unit exceeded. So the number, so the fine depends on how much they actually exceed the S star, and also a fixed amount D, okay? So the first firm cost is given by the following equation here, and we can look at that in the following way in terms of the fine. So if they emit more than what they were supposed to, where they're gonna end up? They're gonna end up in the following situation where there is a probability of them being caught times how much they actually have to pay. And how much they have to pay depends on two things. One is basically what I said before, is the fixed amount plus S star, plus F, which is what they're gonna, the fine they're gonna have to pay, which also depends on the intensity. So how much they actually exceeded S star. If they actually emit less than that, they're not gonna have to pay any fine, okay? So the firm's problem when E is greater than S star is given by the following equation here, right? So they're just trying to minimize their total cost. And the way that they think about it, about this point in here, is they're going to try to think about the expected fine. And notice that the expected fine depends on two different things. It depends on, one, how much emission we actually emitted, right? If it's above or below, but also about the probability of being caught, all right? Right, so we can set it all together here. First order condition gonna given by that. So what the firm's best response to this situation is basically to just equate the marginal saving to the expected fine, okay? So the firm will pollute at the point where MS from emission equal to the marginal expected fine. And again, the fine here, the expected fine is the crucial bit, okay? We're gonna think about that. This is what they really need to think about, all right? So here, this is just two figures here that are gonna show you how, how firm might react differently given the different cost structure that we have here. So the first graph here shows a firm with a relatively flat cost curve here. The firm chooses to produce at S star and doesn't violate the regulation, okay? Why? Because they're just gonna think about the operator at the bottom of the total cost curve, right? This is what they're gonna do. In this case in here, the bottom of the total cost curve is actually above S star and they're gonna be here, okay? So in this situation here for this firm, it's actually make a lot of sense, depends on the cost structure, on the cost function to emit more than what is actually, what is the desired level of emission that they want to have. Okay, so I'm sorry that I ran through it, but I just want to make sure that we finish that before the other people come in. All right. Now, since the firm cares about the expectant fine and auditing is costly, then the regulator should audit infrequently and use a big fine. Why? Because what the firm really care about is not necessarily the fine, is the expected fine. So it's not that, so they care about two things. How likely that someone will come to my plant? And second, what will be the fine if someone comes to my plant and they see that I emit more than what I actually should have emitted. And this is what they're going to take into consideration for making the decision about how much to emit. So there are two things that you as a regulator can play with. Okay, this is really important. One is how many times you go and audit a firm, which is costly. And the other thing, because it's the product of the two, right? Second thing is how big is the fine. So what I'm trying to tell you, that if you want to save money for yourself, you can reduce to the minimum the probability and increase the fine. Because the probability, right, basically costs you money as a regulator. And the firm, what they care about is the expected fine. Okay, what's the likelihood that they're going to be caught times how much they're going to get, how much they're going to have to pay if they get caught. So as the regulator, because the probability costs you money in a way that basically sending people to firms is going to cost you money, you want to reduce that to the minimum possible. Now, you can't increase the fine to infinity almost, right? Because you can't fine a firm more than the total assets that they own. But you can play with these two things together in order to get the right regulation for you. Because what firms cares about is not just the level of the fine, it's also about they care about also the probability of being fined. And you'll be surprised how many people don't get it right. So you see lots of papers that, they didn't really care about the fine. No, they didn't care, but when you look at the valuation of different policies, they didn't care about the fine because they know that there is absolutely no chance they're going to be, visited, or vice versa. Okay, even if there's going to be a chance that, high chance they're going to be, that someone's going to catch them, the fine not going to be high enough. What they need, what really matters here is the product of the two. Because this is what firms care about, all right? So that's kind of the point that I'm trying to make here, and I think that many people kind of get it wrong, okay? So it's not, it's not necessary to monitor firms perfectly because it is expensive to send people all the time or to put equipment that, check all the time. By the way, even if you put an equipment in a facility, it doesn't necessarily mean always that you get the true value because there is lots of gaming around that. Or sometimes it doesn't work. There are some papers that looked at kind of actually firms do it strategically. Okay, we're going to talk about one of them tomorrow, on Wednesday. Okay, so they make decisions deliberately to kind of try to avoid been found in violation of the regulation. Or even, we try to do something about doing kind of a competition between people about how much they can reduce pollution. But the biggest problem that we have, we didn't know how to prevent people from cheating, right? We basically tried to make them reduce indoor air pollution to the best of their ability. But then what people can do, if you put a monitor, they can just put like a plastic bag around the monitor or something like that, and they can obviously win, right? We can't put necessarily a camera on it to make sure that it works. So these things are real. Okay, so that's what I'm trying to say. But if you still need to do this kind of checkup, these things are expensive, and you might want to use the level of the fine in such a way, in such a manner that actually reduce the cost associated with that, because what firms really care about, again, is the expected fine rather than just the total fine. I'm sorry that I had to rush through the last bit of the lecture, but it's quite an important bit. I know there are a few questions. I know there is a lecture after that, so I'm just going to wait outside and feel free to come and ask me. I'm not going to see you next week. Please do your readings and catch up. Book an office hours with me if you don't know something or don't understand, and I'll see you on Wednesday morning.